Let me compare this solution video with a soccer game or a football game, as you like it to call. Let's have the kickstart. This first question is asking us to sketch the graph of this function. So we can see that it is a factored form of a cubic function. So factored form is the best. That means we have a very good start of the game. Let's find out the x-intercepts and y-intercept, because they are stating the intercepts with the coordinates. So for x-intercept, we put y equal to 0. That means we will put this y equal to 0. So what do we get? Let me write it here. 0 equal to 1 minus 1/4, 2x plus 1, x minus 3, x plus 4. So whenever there are certain expressions multiplying and they are equal to 0, that means each one of them could be 0. Then their multiplication will be 0. What is the first probability? Minus 1/4 is 0. Not possible. Yeah, it's a constant. It can't be possible. So that's not helping us. This 2x plus 1 could be 0. So 2x equal to minus 1 and x gives you minus half. That means the first x-intercept is minus half. Let's write some scale on this graph so that I can mark it. So minus half is going to be here, right? Next, x minus 3 equal to 0. It gives us x equal to 3. That means 1, 2, 3. Positive 3 is another x-intercept, right? Third, x plus 4 equal to 0 and x is equal to minus 4. So this is minus 1, 2, 3, 4. This is the third x-intercept. It has 3 x-intercepts and that makes sense. It's a cubic function, so 3 x-intercepts, okay. Let's talk about y-intercept. So when x equal to 0, we get y-intercept, right? X equal to 0. That means in this whole equation of function, put x equal to 0. Let me do it below here. So y will become minus 1/4, 2 times 0 plus 1. Correct? That was the first one. Then x minus 3, 0 minus 3. Then we have 0 plus 4, and mistakenly I wrote a plus here, so don't have. Okay, so these zeros will not be counted as they are. So 1 times minus 3 is minus 3, minus 3 times 4 is minus 12. So minus 1/4 times minus 12, that gives you positive 3. So y-intercept of this graph is positive 3, and let me show it here. 1, 2, and 3. So this is y-intercept. We got x equal to 3, x equal to minus half, and x equal to minus 4 as 3 x-intercepts. Now I have to join them to draw a graph. Cubic graph could look like this or look like this. When the leading coefficient is positive, this is the shape we get. When leading coefficient is negative, we get this shape. And our leading coefficient minus 1/4 is negative. That means we'll get this shape. And let's see if we are getting this shape or not. And yes, it makes sense. Why? Because we need to connect this minus half with 3 and then to this plus 3, and then we will connect negative 4, and that is the shape we were expecting. And yes, that is not a good looking graph, but yeah, this is how it is. Let's move on to the next one. A particle moves in a straight line such that its velocity v meters per second at time t seconds after passing through a fixed point O, okay, is given by v equal to this. Find the speed of the particle. This is an open goal. Yeah, we can just substitute 1 in this. Okay, just 2 marks. And we'll get our velocity and we'll convert that into speed by keeping the sign positive. That's it. So yes, it's an open goal. The game is going on. E to the power 3 to the 3 times 1 minus 25. So V equal to E cube minus 25, and V equal to, let's put this in my calculator and see what do I get. By the time I do this, I would like you to play this game with me and subscribe to my channel and like and share this video with your friends and make it enjoyable for them as well and motivate me to make more videos. So when I put this in my calculator, I get minus 4.914. But we write our answer in 3 significant figures, so it will be 4.91 and no negative because they are saying speed, not velocity. So you will write it. This is the speed. Next question. Solve the equation. And yeah, after open goal, we have been penalized with a penalty kick. Why? Because we don't have a quote in our calculators. The angle is not normal. And we have to just find answer between 0 and pi, not 2 pi. That means we are limited from between 0 and pi. Is really a very difficult penalty kick. Cot is not our cup of tea, so let's convert it to tan. So we know that cot is reciprocal of tan. So cot theta is reciprocal of tan theta. That means if I reciprocate cot, I will get tan. So let's write tan square 2x minus pi over 3. It does not look like, but I have actually reciprocated it. I have made it upside down. So if I have reciprocated tan, I have to reciprocate this 1 over 3 also. So it will become 3. Now to get rid of this square, we want to be in terms of tan, which is in our calculators. I will square root both sides, and when we square root, we get plus and minus both. So square and square root cancel. This gives us tan theta, not theta, x minus pi over 3, and it is rather it is 2x. Pi over 3 equal to plus minus square root 3, and now it becomes simpler, not simple, but simpler than before. So now, because the angle is too complicated, we will go beyond our boundaries. Let's see what are our boundaries. First of all, we will do tan inverse square root 3. No plus minus. Plus minus will help us to find quadrants where it falls. So tan is positive here and here. Tan is negative here and here. That means we'll get answer in all 4 quadrants, even though they have given domain from 0 to pi. But this 2x and this minus pi by 3 will bring us beyond the boundaries. So we will not look at this 0 and pi yet. We will try to answer all of them. So what is tan inverse square root 3? If you use a calculator, it's a very famous value which will be got pi over 3, 60 degrees, pi over 3. So we will draw pi over 3 in all 4 quadrants. This is the relative acute angle. Let's start one by one. We have to start from 0, correct? But whenever you have this kind of angle, 2x minus pi over 3, please start before the limit. So not 0. Start from, say, this line. Okay, let's start from this line. Maybe this line will bring us with between 0 and pi. Let's try that. So 2x minus pi over 3. This is the angle. Let's make it equal to, this is 0. And we are going opposite direction. This is minus pi by 2. And this is minus pi in this direction. And this angle, this particular line is pi by 3 more than minus pi. Okay. So we will write minus pi plus pi by 3. So now we can make it a simple equation by bringing this pi by 3 to the other side. Minus pi plus pi by 3 plus pi by 3. Right? And if we put this in our calculator, I can make it 3 over 3. So it becomes what? Minus 3 pi plus 2 pi minus pi by 3, 2x equal to, so that means x is equal to minus pi by 6, because this 2 will go and multiply with this 3, it becomes minus pi by 6, which is not in our domain, the one 0 to pi. That means it was a wastage of time, but please, it's worth it. Do it. Okay? Even if it is not acceptable, this answer is not correct, still do it. I would recommend. In previous videos also I have mentioned so. Always try to go beyond boundaries. So let's go to the second one, which is this angle. So 2x minus pi by 3 will be equal to minus pi by 3 this time. Okay. So 2x equal to minus pi by 3 plus pi by 3. When this minus pi by 3 goes to the other side, they cancel out. 2x equal to 0. So x is 0 over 2, which is 0. This is first acceptable answer. Are they saying equal also? Yes, it is 0 included. So yes, 0 is our correct answer. We got our first answer even though we went out of our boundary. Let's go to the third answer and we'll go to positive direction now. This pi by 3, this one. So 2x minus pi by 3. Let's give them some numbers. So first one's answer was x1 equal to 0. Let's call it x2. Minus pi by 3 equal to positive pi by 3. So 2x2 equal to pi by 3 plus pi by 3, which is 2 pi by 3. Now this 2 will again go and multiply with 3. So x2 becomes 2 pi by 6. And this cancels here. Answer is pi by 3, and which is within our domain. Correct. This answer is also acceptable. Let's go to the next angle, which is this one. Okay. Let's do it here. So 2x3 minus pi by 3 equal to, what angle is that? That angle is plus pi, in this direction pi is positive, minus pi by 3, pi minus pi by 3. That is the third angle, pi minus pi by 3. So 2x3 remains here, pi minus pi by 3, and we get plus pi by 3 from the left side. They cancel out. So x3 becomes this pi divided by 2. This is our third angle, which is within our domain. Let's go to fourth. And we will have to go beyond our limit again. So we'll go to this angle now. Okay, in this direction, this line did not work, but maybe in positive direction, it will work. So 2x4 minus pi by 3 is equal to pi. This pi plus pi by 3. This is extra angle, right? After pi. So let me redraw this. Maybe it becomes too complicated. I'm going this one. Pi by 2, pi, and pi by 6 extra. This is what I'm going here. So this is pi and pi by 6. Not pi by 6, pi by 3 more than this. Pi plus pi by 3. That's what I'm going to use. The next one, it will be pi plus pi by 3. So 2x4 equal to pi plus pi by 3 plus pi by 3 again. So if I make it 3, it becomes 3 plus 1 plus 1, 5 pi by 3. 2x4 equal to 5 pi by 3, and then this 2 will multiply with 3, it gives us 5 pi by 6. Yes, this is also acceptable answer. 4 answer till now. We can go to the fifth one also, but 5 pi by 6 is very, very close to pi. I don't think the next one will give us an answer within our domain, so we can leave it here. If you want to try, you can, but I'm sure because 5 pi by 6 is very, very close to pi. The next answer could be this one. Let me show you. This, go to here, go to this, and this line you can use, but I'm sure it will not give you right answer. So we are stopping here. This is our final answer. So we have got 4 answers for this. Okay, let's go on to the next one. Find the first 3 terms in ascending powers of x square, not x. Or if they would have written x, that would be also okay, but they have written x square because of this x square. In the expansion of this, write the coefficients as rational numbers. All right. So let's do it here. So 1 over 2 minus 2 over 3x squared to the power 8. This is what we have to expand. So whenever we have to expand an increasing order of x, we should give preference to x. So let's start with 0. That means x has a 0 exponent. That means x in this case is minus 2 over 3x squared. So I will write minus 2 over 3x squared to the power 0. The same number which I wrote here. And the second component of this binomial is half. We give all 8 exponents to it. 8 plus 0. This number should be the sum of the two, 0 and 8. That's the rule. Next one will be 8c1 minus 2 over 3x squared again, and this will get exponent 1. So 1 has been given to this, so half will be left with exponent 7. So third, let me write here 8c2 minus 2 over 3x to the power, you guessed it right, 2, half to the power 6, right? And let's simplify this. 8c0, anything c0 is 1. This is power 0. Anything power 0 is 1. And 1 over 2 power 8 will be 1 over 256. Minus. Why minus? Because this one has power 1. This negative will be negative and it will make everything negative. So that's why I wrote negative here. 8c1 will be 8. 2 over 3x squared is 2 over 3x squared, no change because power is just 1. And 1 over 2 to the power 7 will be 1 over 128. Third, 8c2 is 28. And the square of 2/3 will be 4 over 9. I forgot to write x square here. So it has to be x square square will be x to the power 4. And 1 over 2 to the power 6 is 64. And now we can write the final answer, which is 1 over 256 is 1 over 256 because 1 and 1 will not change it. And here 8 times, okay, 8 can go here, becomes 16. 2 cancels here, 8. So 3 times 8 is 24. So 1 over 24 minus 1 over 24. And we have x square here. So x square. Now here 4 will cancel with 64, which is 16. And 4 times 4 is 16. 4 times 7 is 28. So what is left in numerator? 7x4 plus 7 over, okay, what is left in denominators? 9 and 4, 36. These are the first 3 terms in ascending powers of x square. Let's go to the next one. Find the coefficient of x square in the expansion of this. So the first 3 terms of this will help us to get that. So let me again copy what we got in first part. 1 over 256 minus 1 over 24 x to the power 2 plus 7 over 36 x to the power 4. And let me write the expansion of this. I hope you understand this. A plus b whole square is what? The identity is a square plus b square plus 2ab. So that's what we will write here. 2x square, 2x whole square, right? Plus 1 over x square plus 2 times 2x times 1 over x. This is what we used here. And let's get the simpler version of this, which will be 1 over 256 minus 1 over 24x square plus 7 over 36 x to the power 4. Here we get 4x square because square applies to both 2 and x plus 1 over x square plus 2 times 2 is 4 and x cancel, just 4. And now we can easily find the coefficient of x square through this. How? What should I multiply with the constant so that I get an x square? I have to multiply an x square. So that means I will multiply this x square with this and I'll get an x square. Let's do it. 1 over 256 multiplied by 4x square, which will be, this and this cancel, 64. 1 over 64 x square, right? Secondly, I want to multiply minus 1 over 24 x square. What should I multiply this with so that I get an x square? A plain constant. That means this will multiply with 4 and we'll get a plain constant with x square. 24 x square times 4. 4 and 24 cancel, we get 6, equal to minus 1 over 6 x square. See, we got x square here, we got x square here. Now we have x to the power 4. Obviously, a division by x square will make it x square. And we'll do the same. 7 over 36, x to the power 4 is numerator multiplied by 1 over x square. This x square cancelled with 2 of them, we're left with x square. So it will be 7 out of 36 x square. See, all three are x square. There is no other x square possible. And to find the coefficient, overall coefficient, we'll have to add all these three. So 1 over 64 minus 1 over 6 plus 7 over 36 x square. I took x square common from all so that I just concentrate on these. So their LCM is going to be 576. Yeah. So I multiply this. You can use your calculator to carry out these calculations. I'm using this to show you my mental math. So 96. Okay. This will be 16. So times 16 times 96. So 9 minus 96 plus 112 over 576. So what do we get? 121 minus 25 over 576 is the coefficient of x square. Don't write x square because they are asking only the coefficient. So we will write only the coefficient. Let's pass on to the number 5. A geometric progression is such that its sum to four terms is 17 times sum to two terms. Okay. It is given that the common ratio of this GP is positive and it is not equal to 1. It is positive but not equal to 1. Okay, find the common ratio, find R of this GP. So the formula we should know that sum of n terms of a GP is a r to the power n minus 1 over r minus 1. And this is the formula we'll use here. A r to the power 4 minus 1 over r minus 1 is 17 times a r to the power 2 minus 1 over r minus 1. Both sides a is multiplying, so we can divide both sides by a, so a will get cancelled out both sides. R minus 1 is dividing both sides, so we can multiply r minus 1 both sides, so both gets cancelled out. So what are we left with? R to the power 4 minus 1 equal to 17 times r to the power 2 minus 1. Now, it's a perfect square. R to the power 4 is a perfect square. 1 is also a perfect square. I can write it as 1 square. So, we know there's an identity a square minus b square equal to a plus b, a minus b. And how did I get this hint? Because this is one of the factors which we will write. Let me factorize this with the help of this identity. A square becomes a. So that means square root of r to the power 4 will be r square plus square root of 1 square is 1 and r square minus 1. This is what this breaks into, and we can see that one of the factors is same here, r square minus 1, r square minus 1, and this is what we needed to get rid of. So we will divide both sides by r square minus 1, r square minus 1, they cancel out. So r square plus 1 equal to 17 and this gives us r square equal to 17 minus 1, which is 16. So r square is 16. We square root both sides. R is plus or minus 4, but they have clearly written there that r is positive. Yeah, so we will keep the positive one. R equal to 4 is the final answer. Part B, given that the sixth term of the GP, this GP is 64, find the first term. So AN is equal to AR to the power n minus 1. This is the formula for the nth term. We are saying sixth term. So we will see A6, which is 64, is equal to AR is known to us now 4 to the power n minus 1, 6 minus 1. So 64 equal to A 4 to the power 5. Right? So A we can isolate, it will become 64 over 4 to the power 5, which is 1024. And 64 and 1024 can cancel. It will be 16. So A equal to 1 over 16. This is the first term. Let's go to the next one. Explain why this GP does not have a sum to infinity. Okay, the condition for sum to infinity is that r should be less than 1. Yes, that means what is r less than 1 does? That the second term is smaller than previous term. So an is less than an minus 1. So if your first term is very big, this becomes smaller, smaller, smaller and smaller. So it becomes so small after many terms that this term becomes insignificant if we add all of them. So the condition for S infinity that r should be less than 1, and so that an is less than an minus 1, so that S infinity is possible. So S infinity is not a definite number for r is greater than 1. Our r is much greater than 1 because r is 4. Okay. Next, sixth question. A 5-digit number is made using digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means all 10 digits are there. No digit may be used more than once in any 5-digit number. Okay. Find how many 5-digit odd and greater than 70,000 numbers are possible. Okay. So let's make 5 spaces first. Okay. Greater than 70,000 will be decided by the 3 digits 7, 8, 9. If they are the first digit, our number will be more than 70,000. Correct? But 7 and 9 also make it odd. So they are confusing. They should be here as well as here. So to undo this problem, we should do what? We should isolate 8 and 7, 9. Let's write 8 only. 7 and 9 we'll talk about later. Right? Whenever there's a confusion, separate the ones that are creating confusion. So 8 is the only candidate for the first digit. And now let's talk about the last digit. How many numbers can make this number odd? So it can be 1, 3, 5, 7 and 9. There are 5 possible numbers which will make it an odd number. And now we will see that one number out of these 5 has been used here. 8 is already used here. So we are left with just 8 possibilities for this place, 7 for this and 6 for this, because we cannot repeat the numbers. And whenever we have number of candidates, just multiply them. I get 1680 for this. Let's go to the condition when 7 or 9 is used in first digit. That means we have 2 candidates for this one. 2, 3, 4, 5. Now, let's talk about the unit digit. Can we have 1 here? Yes. 3, 5, and 1 of 7 and 9, because 1 will be used here at this first position. So we are left with only one possibility here. So we can say 7 or 9, one of them, right? So we have how many candidates now? 1, 2, 3, and 4. There are 4 candidates for unit digit now. And similarly 8, 7, and 6, just like before, in these 3 positions, which gives us 2688. Either this will happen or this will happen. When we say or, we add all the possibilities, add 1680 and 2688, and that will be 8, 6, 3, 4. 4368 possibilities are there, which will be more than 70,000 and odd numbers. The number of combinations of n objects taken 3. So n objects taken 3 at a time is 2 times the number of combination of n objects taken 2 at a time. Find the value of n. Okay, so we just have to use the formula which is available in your formula sheet. So nc3 will be n factorial divided by n minus 3 factorial will be equal to 2 times n factorial n minus 2 factorial and 2 factorial. So we can see 2 factorial is 2, this and this cancel out, both have n factorial, they cancel out. So now let's break this n minus 3 into 2 parts. Rather, n minus 3 will remain what it is. This can be broken 3 times 2 times 1, which is 6, okay, equal to 1 over n minus 2 can be written as n minus 2 and n minus 3 factorial. Why? Because we subtracted 1 from here, so that we get 1 factorial here, which is same as this, and now we can cancel this. And what are we left with? 1 over 6 equal to 1 over n minus 2. So cross multiply n minus 2 equal to 6. That gives us n equal to 6 plus 2, which is 8. One thing, let me explain here why this happened. We know that 4 factorial is 4 times 3 times 2 times 1, correct? Can I write 4 factorial as 4 times and this is 3 factorial? That means we can write any factorial with the number which is written here times the next smaller number factorial. That's what I've done. N minus 2 factorial was here, so I wrote n minus 2 times 1 lesser than n minus 2, which is n minus 3 factorial, so that I can cancel with n minus 3, and that's what I did here. That's how I got this 8 as a solution. Number 7 is circular measure. The diagram shows a circle, center is O, its radius is 10 centimeter, okay. The point ABP lie on the circumference, we can see that. The chord AB is of length 14, okay, this is 14. The point Q lies on AB, and the line POQ, okay, is perpendicular to AB. This is perpendicular, they have shown. So whenever a radius from center, a line is perpendicular on a chord, it divides it into 2 equal parts. That is a rule. So this is 7, this is 7, because total is 14 centimeter. All right. So that the angle POA, this angle is 2.366 radians, correct to 3 decimal places. We have to show this. All right. So we know this is 7, right? We know this is 10. So with the help of this 7 and 10, we know this is right angle triangle. We can find this angle, angle AOQ, angle AOQ. Let's call this angle alpha. So let's find angle alpha, and because we know this is a straight line, this line is a straight line, so the angle will be pi, and we can find the angle POA. that they are asking with the help of this angle alpha. So we know that sine alpha will be opposite to this is 7 over hypotenuse. Hypotenuse is 10. That makes alpha equal to sine inverse 0.7, right? 7 over 10 is 0.7. Okay, whatever that is, we will subtract that from pi. This whole line, this angle is pi, and we want PO. So angle POA is pi minus sine inverse 0.7. Just put this in a calculator and definitely you are going to get 2.366. Let me confirm. Sine inverse 0.7. Yes, 2.366. Let's go to B part. Find the area of the shaded region. Okay, the shaded region we can see. Let me show you. I will divide it into two parts. So one part is this sector, this line, and this line. That makes it a sector, right? If this angle is 2.366, this angle will also be 2.366 by the same logic, because the chord is being divided into two equal parts, so same angle will be created here, though that one was created on the other side. So we can find the area of this sector, find the area of this triangle, and add them, we'll get the total area. That's what we'll do. So the area of the shaded part will be the area of the sector plus area of triangle, the ones I have just indicated. Area of the sector is half r square theta plus area of the triangle is AB sine C, where angle C is between the sides AB of the triangle. And let's substitute everything. Half r square theta. Radius is 10 centimeter, we know this, and theta 2.366, we know this, so we can substitute it here. Half 10 square 2.366. This is the area of the sector. Now the area of the triangle, and in triangle we should know two sides and the angle between those two sides, and we know it. This side is 10, this side is also 10, and the angle we just found between them is 2.366. So we have everything here. We can substitute that one also. So 10 sine 2.366. So we can see that half is common in both, 10 square is common in both. Let's write that 100 here. Here we are left with 2.366 plus, this is out, sine 2.366. Just put this in a calculator and you'll get the area. Let me use mine. And by the time I do this, I will again request you to subscribe to my channel. 89% of my viewers are not subscribed to my channel. They miss such good quality videos. And if you subscribe to my channel, like this video, share with your friends, that will motivate me to make more such videos, and we'll get the knowledge shared in the whole world. Once I used my calculator for this, I got 153.301, which we can round off. Three significant figures, 153 centimeter square. C part, find the perimeter of the same shaded region. Let's go back and plan. This is 10, so perimeter equal to 10. This is also 10. This is the next one, which is an arc, PB. And then finally we need this side, which is AP. So 10 we already know, RPB. We can find how arc is R times the angle it is subtending on the center. So R is 10, we know the radius is 10, so we can write here 10 multiplied by the angle it is subtending is 2.366. So got arc PB also. Now AP is the only one left. So let me bring this one here. 10 plus 10 plus 10 times 2.366, which will be 23.66, total 43.66. Let's worry about only AP now, this line. Okay, so 43.66 is already with us. Now only the line PB is left. And let me redraw, not PB, PA. It was PA. Okay, let's redraw that triangle here. This is P, this is A, and this is center O, this is radius. So 10 is here, 10 is here, the angle is here 2.366. Can't we find this side by cosine rule? We can. What is cosine rule? Cosine rule is a square equal to b square plus c square minus 2bc cos a. This formula is always in your formula sheet. So you can see there. What you have to take care that this angle A should be opposite to the side A. The angle we know is this one, 2.366, and what is the side opposite to it? The one we want, PA. So that's it. Let's write PA square. Let's put absolute sign to show that magnitude, equal to B square. The other two sides are B and C. So 10 square plus 10 square minus 2 times 10 cos 2.366. That's the angle we have. So PA becomes square root 100 plus 100, 200 minus 2 times 10 times 10, 200 cos 2.366. Okay, let me find out what is it. When I use calculator, I get 18.51 is the length of PA, and now we know everything. We just write perimeter now. 43.66 was already known to us, so the perimeter is 43.66 plus 18.51, total 62.2, approximately 3 sigma figures. This is the perimeter. Question number 8. The curves y equal to x square plus x minus 1, which is opening up like a parabola like this, and this curve, which is also a parabola, quadratic, so maybe like this, intersect at points A and B. So this is point A, this is point B. All right. Show that the midpoint of the line AB. So if we make a straight line out of this, the midpoint of that is 2, 9. In other words, they're saying find the coordinates of A, find the coordinates of B, and show that the midpoint of these two coordinates is 2, 9. All right. So first we need to know the x coordinate of the points of intersection. So what can we do whenever we want to find the points of intersection of any two functions? Substitute one into the other. We can see y is equal to x squared plus x minus 1. Let's substitute it here in place of this y. So 2 times x squared plus x plus 1 from the first equation equal to x squared plus 6x minus 2. So 2x squared plus 2x minus 2, not plus, it is minus 2. Okay, let's put these also to the left side. X squared minus 6x plus 2 equal to 0. 2x squared minus x squared is x squared. 2x minus 6x, 4x minus 2, and plus 2 cancel. Left, so we'll factor this. Now we'll factor this. We could have done this way. Some of you may do this way. X equal to 4x, x cancels with one of the x equal to 4. But we get only one answer. Never ever bring one of the answers to the other side, or one of the terms to the other side, and you will lose one answer. So best thing is to factor this. X taken common, x minus 4 equal to 0. So we got two x's now, x equal to 0 and x minus 4 equal to 0, which gives us x equal to 4. So the x coordinate of this point is 0, x coordinate of this point is 4. But this is not enough, we need y also. So we can substitute 0 and 4 in any one of the equations, and let me choose the easier one, which is x square plus x minus 1. So let's put 0 here. So y equal to 0 square plus 0 minus 1, which gives us minus 1. So the y coordinate of this one is minus 1. Let's do the other one. 4 square plus 4 minus 1. 16 plus 4, 20 minus 1, 19. And now let's find the midpoint. We have to show that the midpoint is 2, 9. So midpoint will be the x coordinate of this 0 plus x coordinate of this 4 divided by 2, comma, minus 1 plus 19 divided by 2. So 0 plus 4 over 2 is 2, minus 1 plus 19, 18 divided by 2 is 9, and yeah, we showed that midpoint coordinates are 2, 9. The line L is perpendicular to the bisector of AB. So let's do it differently now. So we know the coordinates of A now. It was 0, minus 1, and here 4, 19, and this is 2, 9. So the line L is perpendicular bisector of this. That means it is passing through 2, 9, and it is 90 degree to the line AB. Show that the point 12, 7 lies on the line L. Let's see, it is here, suppose. So if this point is on line L, it should satisfy the equation of the line L. So let's find the equation of line L. So equation of any line is y minus y1 equal to mx minus x1. Y and x don't need to be replaced, so y minus and y1 and x1 are the points on the line. 12, 7 are, we have to show, so we can't use it. So the one we are confirmed are 2, 9. So we'll use the point 2, 9. So 9 is y1, m we don't know yet, x minus 2. Let's find m. M is the gradient, right? So to find the gradient of this, we should find the gradient of AB first, and then we will find the gradient of L. So let me use this space to find gradient of AB. So we know the endpoints. We can take these 2 points. Even 2, 9 can be used, but I'm using the endpoints. So y2 minus y1, 19 minus minus 1 divided by x2 minus x1. So 19 plus 1 is 20 divided by 5. 5 is the gradient of AB. So gradient of line L will be negative reciprocal of 5, which is negative 1 over 5. That's what we will write here. Now we have to show that 12, 7 is lying on this line of which we just got the equation. So we'll just substitute 12 and 7 and show that yes, it is satisfying. So in place of y, we will write 7 now, because that is the y coordinate. 7 minus 9 equal to minus 1 over 5. X is 12 minus 2. 7 minus 9 is minus 2 equal to minus 1/5, and 12 minus 2 is 10. So if we cancel 5 and 10, we get 2. So minus 2 is equal to minus 2. Yes, point 12, 7 lies on the line L. This game is dribbling against us. Let's see what has it for us. Next one, the point D also lies on L, okay, such that the distance D from AB is 2 times the distance of C from AB. Let's see the drawing again. So this is the drawing. We want a point D so that the distance of D, if this is C, D is double. So whatever is distance here, it is the distance here. Alright. But it is also possible that D is on this side. Yeah. They're saying distance from AB, and distance is always the shortest distance they talk about, and shortest distance is the one that makes 90-degree perpendicular distance between the point and the line. Otherwise we could have said that this is the distance between A and B, right? But no, the shortest distance is the perpendicular distance, so I'm talking about the line here. So D could be either here or here, and I think they're asking us the coordinates of D. Let's see. So find the coordinates of the two possible positions C of D. That's what they're saying. So let me do it here. So this is 2, 9 at the base of the perpendicular distance. C we got as 12, 7. So we want a D here. Let's call it D1, so that this distance is equal to this distance. Let's start with this one. So D1. Let's assume that the coordinates of D1 are AB. Right? And we know these two distances are same. That means A minus 12, this A minus 12 will be same as 12 minus 2. Whatever is the x distance between these two, that has to be equal. So let's bring 12 to the other side. A equal to 12 minus 2 plus 12, which is 22. So D1, the x coordinate is 22. Let's talk about B. So B minus 7 will be same as 7 minus 9, this distance. So X we are focusing separately, Y separately, because they do not affect each other. So B will be 7 minus 9 plus 7, and that is 14 minus 9, 5. So the Y coordinate of D1 is 5. Let's talk about D2, which will be on the opposite side. D2. So whatever is the distance between 2, 9 and AB, the one we got now, 12, 5, 22, 5 probably, 22, 5, same will be on the opposite side, right? So we can, let's call it CD. The coordinates here, CD. So C minus 2, C minus 2 will be same as, because the distance has to be same, right? 2 minus 22, the one we got just now, right? Same distance, double the distance of this one. So C will be 2 minus 22 plus 2, 2 plus 2, 4, minus 18. So D2 coordinate will be minus 18, the x coordinate. What about y coordinate? Same thing with y. So this D minus 9 will be same as 9 minus 5. So D equal to 9 minus 5 plus 9, 18 minus 5, 13. 13 is the y coordinate, and these are the two possible coordinates of D1 and D2. Let's see how player number 9, question number 9 looks like. When e to power 2y is plotted against x square, okay, this is x square e to power 2y. A straight line graph passes through 4, 7.96. Okay, let's say 4 is here, 7.96 is here, sir. Okay. And 2, 3.276. Okay, suppose it is here. Okay. And they pass through, the straight line passes through these 2 points. Okay. Find y in terms of x. Whenever you have such a situation, Replace e to the power 2y by capital Y and this by capital X. So we will write the equation of this straight line in terms of y and x, capital Y and capital X only. Y and x we'll look at them later. Alright, so the equation of this line will be y minus y1 equal to mx minus x1. So y remains y, but we know a point here. So this was 3.76, right? So let me take this point. So 3.76 I can write here in place of y1 equal to m, we don't know, but we can write 2 here, this 2. Alright, we have to find the gradient. To find gradient, we should have y2 minus y1 over x2 minus x1, which is 7.96 can be taken as y2 minus 3.76 as y1, x2 4 minus 2. So this will be 4.2 over 2.1. So the gradient is 2.1. We got the equation. There's no need to solve this because they are not asking us to find the normal equation, but we can substitute the values back now. E to the power 2y was the capital Y, so e to the power 2y minus, let me put 3.76 to the right side, equal to 2.1. X is not x, it is x square minus 2, and this minus 3.76 I'm writing after 3.76. So now let's isolate 2y. It will cause the other part to become ln. So it will be 2.1 x square, if I open this bracket, minus 4.2 plus 3.76. So y equal to half ln, let me write this way, 2.1 x square minus 0.44. That is y in terms of x. That was what they were asking. Let's go to the B part. Find y when x is 1. So this is an open goal again. Just substitute 1 in place of this x. So y equal to half ln 2.1 times 1 square is 1. So no need to write it, minus 0.44. So just substitute this in your calculator and the value you should get is 0.253. That's it. Is there any C part? Yes, there is a C part. Using your equation from part A, which is this, find the positive values of x for which the straight line exists. Yeah, we can't have a negative value inside ln here. This cannot be negative. If it is negative, log of a negative is not possible. So we will make this internal part only 2.1 x square minus 0.44 greater than 0. So 2.1 x square is greater than 0.44. So in that case, we will write x square greater than 0.44 over 2.1, not 21, 2.1. Okay, and if we square root both sides, we have to give the positive values only. X is greater than whatever is the positive value of this, and let me find it out. I got 0.458. X is greater than this, then you will get a straight line in part A. Okay. Question number 10. A curve with equation this has a second derivative, this one, for x is greater than 0, that means x is positive. The curve has a gradient of 10. Gradient means dy over dx at certain point, and that point is 319 over 2. When x is 3, y is 19 over 2, the gradient is 10. That's what they're saying. Show that when x is 11, the gradient is 52. So let's find the gradient, general form of the gradient first, and which we will get when we integrate d square y over dx square equal to 2x plus 3 to the power minus half plus 5. So we have to integrate this with the help of dx and this and dx. So let's integrate all parts. This becomes dy over dx, and this is a power of a function. Whenever we have to integrate power of a function, and that function should be a linear one, it is not applicable to any other type of function. So in that case, we add 1 to the exponent, divide by the same minus half plus 1, whatever is the new exponent, and further we divide by the differentiation of what is inside the bracket, and differentiation of 2x plus 3 is 2. Now 5 will give us 5x and we will have c, right? Now our dy over dx is almost ready, but we need to evaluate c before we can apply it. So dy over dx equal to 2x. So we can use this one now, rather we can use this information. So I'm not writing dy over dx anymore. Let's write straight away 10. So 10 equal to, when x is 3, so in place of x I will write 3 plus 3 to the power minus half plus 1 will be positive half. Divide by positive half, this one will be positive half, times 2 will be 1. Half times 2. 2 and 2 cancel, we get 1. So there's no need to write any denominator. Plus 5 times 3 again, and plus c. So 2 times 3 is 6, 6 plus 3 is 9, square root of 9 is 3. So 10 equal to 3 plus 5 times 3 is 15 plus c, and 3 plus 15 becomes 18, and 10 minus 18 equal to c, and c comes out to be minus 8. So finally this equation with c becomes finally dy over dx equal to 2x plus 3, and the exponent is half. I can write square root here, and denominator was 1, so ignore it, plus 5x, and now c is minus 8. Now they are asking us to prove or show this one, so we'll substitute x by 11 and we should get 52. Dy over dx as 52 at x equal to 11. So dy over dx equal to square root 2 times 11 plus 3 plus 5 times 11 minus 8. 22 plus 3 is 25, square root of 25 is 5, plus 55 minus 8. This becomes 60, 60 minus 8, 52, exactly what they were expecting. This is next. Find fx, the main function. To find fx, which is actually y, will be achieved by integrating again dy over dx. What was the equation? This was the equation. So we will integrate that equation. So integration of dy over dx with respect to x equal to integration of square root. In place of square root, let's write again power half. That will make it easy to integrate. 2x plus 3 to the power half plus 5x minus 8 dx. So this will be y, left side. The right side, again power of a function. So 2x plus 3, 1 added to the exponent, same exponent was 2. Same exponent will be written here, and we divide it by the differentiation of what is inside, 2x plus 3, differentiation is 2, plus 5x square over 2 minus 8x and new c. We have to evaluate this c again, and we knew that there is a point here on which they have given this one. When x is 3, y is 19 over 2. So we will substitute y by 19 over 2 and x by 3. So 2x, which is 3, plus 3 to the power, how much? Half plus 1. 3 over 2 divided by 3 over 2 times 2. This 2 and this 2 again cancel out. Plus 5, 3 square over 2 minus 8 times 3 plus c. C is the only thing unknown now. So let's see what it gives us. 2 times 3 is 6 plus 3, 9. Square root of 9 will be 3 and 3 will be 27. 9 to the power 3 over 2 is 27. How? First we find 1 over 2 square root. Can we write this as 9 over 1 over 2 and power 3? So 9 to the power 1 over 2, which is square root, is 3 and 3 cube is 27. That's why I said this will be 27. So 19 over 2 equal to 27 over 3 plus 3 square is 9 times 5, 45 over 2 minus 24 plus c. So c will be 19 over 2 minus 27 over 3, which is 9, minus 45 over 2, 45 over 2 plus 24. Yeah, they will change their signs. Let's see what we get c. So 19 minus 45 will be 26. Yeah, minus 26. Minus 26 over 2 will be minus 13 minus 9 plus 24 equal to c. So 24 minus 22, yes, c equal to 2. And the final equation for y will be y equal to 2x plus 3 to the power 3 over 2 over 3. I'm writing that equation again, okay? The one which we left in incomplete there. Plus 5x square over 2 minus 8x, and now c is 2. Let's kick on with the next question number 11, which is the final question of the exam. A curve has this equation: x is greater than minus 1, dy over dx, we have to show that it is equal to this, where a, b, c are integers. Simply differentiate this. So dy over dx, if y is this, will be, we'll use quotient rule because this is a rational function. So in quotient rule, let me go at a straight line. X plus 1 square, and then the same x plus 1 will be written here, denominator, but we will differentiate the numerator. X square minus 5 to the power 1/3 is differentiated, minus the numerator is written as it is, and denominator is differentiated. So x plus 1 is x plus 1. This is power of a function. So the power comes in front, becomes coefficient. The contents remain same, but the exponent is decreased by 1. Further, we multiply this, multiply, not divide. Like in previous question, we divided by the differentiation of what is the content of the bracket. Here we'll multiply, which is differentiation of x square is 2x minus 5 is nothing, minus x square minus 5 to the power 1/3, and differentiation of x plus 1 is just 1 divided by x plus 1 square. Okay, so let's simplify this. X plus 1 remains x plus 1. Let me give it a denominator 3 so that I merge these two. 1 over 3 minus 1 will be minus 2/3. So minus 2/3 is the exponent. To make it positive, I will make this also a denominator. X square minus 5 to the power positive 2/3. And there is 2x as well. So I will write 2x here. Okay. Minus. What is here? X square minus 5 to the power 1/3 and nothing else. Divided by x plus 1 square. Now, there's a problem here that we have a fraction inside a fraction. The rational number, rational expression, this one left side, inside a rational expression. So, let's get rid of it. How? This is a denominator 3 and x square minus 5 2/3. Let's give the same denominator here as well. 3 x square minus 5 2/3. And nothing is free in this world. We have to compensate this by multiplying the numerator also by 3 x square minus 5 2/3. And now in next step we can merge the two because now they have same denominator. We'll make them 1. 3 x square minus 5 to the power 2/3. So what is left on the numerator? It is 2x multiplied by x plus 1 here. Minus. And look at this, 1/3 and 2/3 will make it complete one because the bases are exactly same. So it becomes 3x square minus 5. So things which were complicated became a little simpler, but we have a further denominator. But I'm not writing that denominator yet. Why? Let me give you an example why what I will do with that one. So suppose I have a 3 over 5 over 4. Suppose I have this one. Okay. Can I write this as 4 over 1? Make this also a rational, which can be written as 3 over 5 divided by 4 over 1. We can write that further as 3 over 5 multiplied by 1/4, and the answer is 3 over 20. That means we can multiply the middle one and we can multiply the corner ones in fraction inside a fraction. So if I make this also divided by 1, we get the same situation that we will multiply x plus 1 square with the denominator of the numerator. So basically I'm going to multiply x plus 1 square and no change with the numerator because 1 will not make any change if I multiply 1 with the numerator, and this became the simplest form. But the format they want is ax square plus bx plus c. That means I have to simplify the numerator. Denominator is exactly what they want. Yes. So it becomes 2x square plus 2 minus 3x square plus 15 over 3x square minus 5 power 2/3 and x plus 1 square. So 2x square minus 3x square will be minus x square. There is no x. It will be 2x. There is plus 2x, right? Okay, plus 2x and plus 15 over 3x square minus 5 2/3 x plus 1 square. So comparing this with the format they want, a is minus 1, b is 2 and c is 15. And here is the b part. Find the x-coordinate of the stationary point on the curve. Okay, so we know that for stationary point, we have to write dy over dx equal to 0. So what is dy over dx here? This is dy over ds minus x square plus 2x plus 15 over 3x square minus 5 to the power 2/3 x plus 1 square equal to 0. The complicated denominator, when it multiplies with 0, becomes 0, so we are left with only the quadratic part, which is the numerator. And this will give us 2x values because it's a quadratic equation. And let me use factoring method to find this. You can straight away put this in your calculator and you'll get the answers. So let me use it. Minus x square plus 5x minus 3x plus 15 equal to 0. and x, rather minus x, let's write minus x minus 5 minus 3x minus 5 equal to 0. So we get minus x minus 3 x minus 5 equal to 0. This part gives us minus x minus 3 equal to 0 minus x equal to 3, or x is equal to minus 3. This gives us x minus 5 equal to 0, x is equal to 0. We got the x coordinate, and they wanted x coordinates only, not the y coordinates. Alright, C part. Explain how you could determine the nature of a stationary point. So first we find second derivative, right? Then substitute x coordinates we got in previous part into that second derivative, right? If second derivative, let's say f double prime x, is greater than 0, positive, the stationary point is a minimum, because negative means the at that point the curve is opening up, and that's why this stationary point is a minimum, and vice versa. If second derivative is a negative, the stationary point is a maximum.